All right, so here we're going to talk about the second graph for today. And as you guys can see, I kind of just want to start with some points and some topics on absolute value, because absolute value is a topic that we have discussed in previous math classes, but we really haven't dove into the true meaning of it. So let's pick our brains for a second. If we're talking about the absolute value, a lot of students just like to say, oh, it takes a negative number and it turns it into a positive, which is true. But why does that happen? So if we're looking at the absolute value of 2, and we're looking at the absolute value of -2, they're both equal to 2. If we're looking at this number line right here, we see that we're dealing with the number of -2, and we're dealing with the number of 2. They are both 2 spaces away from 0, which is why the absolute value works. The absolute value of -2 is +2, because you don't talk about distance and moving from left to right in terms of a negative value. You just say it's 2 units, 2 spaces away from the origin. So that's kind of where we get that absolute value from. So what does this graph look like? Well, let's do what we did above and let's plug in some inputs and outputs, right? We're not looking for any magical numbers to appear. We're just trying to figure out, hey, how do we get these numbers, right? Well, if we start with 0, the absolute value of 0 is just 0. Now notice, we're not using our calculator for any of this. We're just simply talking about inputs and outputs, right? All right, well, if we have 1, the absolute value of 1 is 1. And if we have 2, the absolute value of 2 is 2. Okay, positive to positive, easy peasy, right? But if we're looking at the absolute value of -1, our value is +1. And if we're looking at the absolute value of -2, our y value or our output is +2, and so on and so forth. So what would this graph look like? What would the parent function of the absolute value graph look like? Well, its vertex is still at 0, 0. And really, we're just moving up in a linear fashion. 1 to 1, 2 to 2, 3 to 3, and so on and so forth. Now, if we go and plot these negative points, -1 to +1, -2 to +2, -3 to +3, and if you take a look, this graph looks a little bit like the quadratic function in the sense that, it's moving in the same direction. But if you look, all of these plotted points are very linear, right? I don't have a ruler next to me right now, so that's a bad teacher move on my part. But all of these lines are very, very linear. There is a constant rate of change going on in the absolute value in this parent function, right? So what that also tells us is that the quadratic function is moving at a faster rate, right? You're going from 2 to 4, 3 to 9, 4 to 16, whereas the absolute value parent function, it's moving very linearly, 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5, and so on and so forth. So some of these key points that we see are obviously 0, 0, 1 to 1, 2 to 2, and so on and so forth. We can go the opposite way, -1 to 1, -2 to 2, and there you have it. Now, with domain and range, not a whole lot happens here, right? Because if you think about it, in terms of x, your x could be anything positively and anything negatively. So our domain, we're still looking at this of -infinity to +infinity, right? All real numbers. And our range, if you take a look at this parent function, nothing's happening down below right here. So our range is also from 0 to infinity with, remember, that interval notation is super important. 0 is like a hard 0, right? Nothing can go below that, and no number less than 0. And infinity, that's really an unknown to us. We know it's this value that's super large, so we have to leave the parentheses open. So this is just a little introduction to the absolute value parent function, okay? We have to know that it's a V-shaped graph. We have to know that it's a linear rate of change. And we have to know, what some of these key points are, all right? So let's head over to the next video where we're going to learn about the cubic parent function.